Well, this is a weird one. Why would I jump twice to point 2? Oh, it's clamping. Should never clamp to 2. 2 is a range, but it's not flat. Nothing makes sense. Is flat. What did I call that thing? Just a packet. Well, it looks like I'm... No. What? Ah. Oh, right. I think I confused. It is confusing. So I confused the left here. The left min is actually on the right. Yeah, so this is a maximum. And then this cubic has the type, well, right max, because it is on the right. Oh, wait a minute. The two, I'm testing two. It's even worse. So this is the left part of a minimum. This part. I'm not even interested to test that really. I just want to test this cubic. Yep, the code is completely wrong. Left. Yeah, I must only test right off. And then is flat at Yeah, well. Hello, Duke. Yeah, if it is about my projects. Otherwise, it's a bit distracting. Range edge jump. I want to catch these this in a single member function of Rydle. I can't do that. I have to call this, which is an algorithm thingy. Yeah. Yeah, where do I put it? Completely forgot where it is. Damn it. What's that thing called? Q to next sample type or something like that. What are the benefits of doing this object-oriented? Well, that it is object-oriented. All the benefits of object orientation. Efficiency. No, why? You could write it in assembly. It's probably more efficient. Wait, you can't write it in assembly. It's too difficult. I've read it object-oriented because it's complex enough. And I wouldn't be able to wrap my head around it if it was not object-oriented. Normally, I would say object orientation is what I need, among other things, to make the code more robust also. That is, suppose you are a god coder and you never make a mistake, you have a 100% overview of the whole project all at once. You know exactly what you're doing, you know all the algorithms. And you just start typing and you don't stop typing until the program is finished. And then years pass and you get older and your memory degrades, or you just leave the company and someone else has to take over. Because the God coder would be able to do anything, right? That's per definition of God. So that guy leaves, and then you have a program, and you want to make a change. And then I think that if a big complex program is not object-oriented, then making a change introduces bugs. So you make a change, you think you're doing it right. But yeah, I mean, if you pull a string on one end and then on the other side of the house of cards something moves, and you have to pull another string and again and again, and every time you change something to fix something, then I mean, you start with changing something because you just want to change. You want to add a feature maybe, or, you know, something like that. But once you start changing things, you introduce bugs, and then you have to make more changes because you have to fix those bugs. And then if your program is really unmaintainable, then every change introduces more bugs than that you fix. So it becomes more and more unstable until you just have to delete everything and start from scratch. And that point of complexity, where that happens, is a lot more complex when the program is written object-oriented. So the benefit of using object orientation, I think, is mostly that your application is still maintainable even at a very high level of complexity. Maintainable and robust. I mean, maintainable is when it doesn't come tumbling down like a house of cards when you make changes. Robust is more like, yeah, you can make a change and it still works. I mean, the code that I write is usually very robust. I can just make absolutely crazy changes, like change thousands of lines of code all over the place, and not even perfectly, but you know, I don't know what I need to change. I just know that at least there and 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 there I want changes. And then at some point I fixed, say, 30%. And then I just start compiling. And you get compile errors, which force you to fix it. And then by the time it compiles, it works again. That's the true definition of robust. You need more than object orientation for that. I need tests. I need tests. In what context are you asking that question? Are you offering me to do tests, or do you mean, do we need tests to become to get the robust code, or what? I think tests usually don't help much. No. Some. I mean, I write tests while I'm coding, right, while I'm running an application, but the companies that just write a test for everything with the idea that once the test suite runs and runs 100% till completion, it works. That's just not true. So what I try is when it compiles, it works. And if you have a house of cards and it's really not robust and it's not maintainable, but you have a huge test suite and you just keep adding clutches and workarounds and hacks until the test suite works, then it's not working. Only the test suite is working. And you can never test every in and out. So then you still have a pile of shit that will fail in production, in real life, in you know, out there, outside the test suite. Maybe it will work in most cases, you know, like the normal cases. Most people click here and then they click there. And that's by far most people do that, and that's what you tested, and that works. And then the occasional guy that first clicks here and then there, in the other order, they get some obscure bug because the code is bugging. But you still make money because, just ignore that guy. Tell he did something wrong or something. They'll never know. I'm going to concentrate on my code again, because otherwise I forget what I was doing. I'm in the middle of something. Yeah, I added this here because it has to do with relationship between these bits. So this is the difference between left and right. So what I could do is just right here, the min bit shifted to the left. And these are the same thing, but I shifted this much to the... Well, I'm shifting it the wrong way. I want to make them larger. So you could do, this is itself shifted 0 bits. Yeah, well, yeah, forget it. So we go from here to there by shifting 1 bit. But I also want to go from here except I am not calling it isFlat anymore. What did I call it? Bit to test. Bits. We don't have bits. SampleNode here. Something in SampleNode. Bits. It's now called LocalExtreme. Could make this an enum. Maybe of course I should make it an enum. Just enum number XYZ. Very tiresome. Yeah, is it really necessary? Okay, now I completely lost what I was doing. Seriously. I know you're finally getting what the... Okay, this is what I was looking for. I hope it's still have it in my mouse buffer. Yeah, has LocalExtreme. That is form of SampleNode. Yeah, but I add 1. So then it becomes 0 or 2. 0 for minimum and 2 for maximum. So the maximum is shifted 2 compared to the minimum. So you have left min bit and then you have left max bit. It's shifted 2. So it's just, and that 2 I obtain then by adding 1 to the enum that says minimum or maximum. So minimum is -1 plus 1 as I don't shift it, and maximum is +1. +1 is 2, and I shifted 2 for the maximum. Did I miss a right min bit there? Right min bit. Right min bit. That is shifted 1. Right min bit is the left min bit shifted 1. So I add the side of cubic with this 0 or 1. Okay, remove this assert because it's an enum, so it's definitely not going to be anything else. This is all very obscure, but since it is in one place and then completely shielded from shielded from anything outside the API, you just end up with this. This is the API, and just don't look at what happens here. And he said, well, but why do you write this unreadable code? Because I'm a speed freak. It's bullshit, I guess. Yeah, but this is a branchless test. It's inlined, and then the only thing it has to do is add a few integers, and the one is probably free. And do a shift, and then a bitwise AND, and then of course that automatically sets the 0 flag that you can jump on then, so this is not really done either. And then we can jump on that flag where the hash flat extreme was being tested. So all in all, there's going to be 1 or 2 clock cycles without a branch. And then I'm willing to have some unreadable code, as long as this is understandable. And I can kind of read it. It says it has a flat extreme of this type on that side of the cubic. It even says it. It's a bit contrived, but hey, in the end. And we missed it again. Okay, plop, run. Let's see what happens this time. And we still crash. It just keeps crashing. So we should come here twice, I think. Yep. How many viewers? 5 viewers. I'll explain again what is exactly happening here. We add 0.0. This is a test suite. The test is finding . Yeah, well, finding some local extreme, and it is going to find the minimum first, and after that it's going to find that maximum. But really this is a part of the test suite where we just find the first cubic, so it might abort really soon. Anyway, the test suite uses a cubic as function, and we drop the first point here, 0, exactly in this maximum. And then the algorithm wants you to return the value of this point. Yeah, that's just a step to that side. But the test suite ignores that and says, yeah, I don't care what you want. I'm giving you this point. So it gives you first it gives 0 with a value of what was it, 447 at -3 and a derivative of 0, and then it gives the algorithm this point. At that moment, the algorithm has 2 points, so you can fit a cubic between 0 and 1, which of course is this whole cubic, but okay. We also have the piece between 0 and 1. And then it says, yeah, well, where shall we go first? Shall we go to the maximum or shall we go to the minimum? So completely random, because it's so symmetrical as possible. It decides to go to the minimum. So it uses this cubic, which is a mathematical cubic, so we know where the minimum is. And we jump to that minimum, which happens to be exactly where we were before, which means that we didn't make any progress. So, you know, I mean, we were in 1, and then we do one step, we jump to the minimum of the fit cubic, and then we're still there. So that means that we were already in the minimum. We were not in the minimum, and then we would have now jumped to that, and we would have been somewhere else. So at that point it says, hey, we found a minimum. And then it wants to mark this cubic between 0 and 1, which was the cubic that was used, the local minimum of this cubic was used to find this minimum of the real function. It wants to mark that as what I call a local extreme. Now, cubics, however, are stored in the sample nodes on the left of the cubic. So node 0 would get a pointer to an object of type LocalExtreme, which then says this cubic, the cubic from 0 to 1, was used to find the minimum. And then you can ask it, okay, where is that minimum then? Well, you have the cubic, and you also know the minimum. So in this point then we store that there is a minimum here. But that can potentially give problems, because this is also a maximum. So what it can't do, and therefore doesn't want to do, is mark a cubic. In this case I'm talking about a piece of the cubic, namely the one between 0 and 1, as a local extreme cubic, if that has 2 extremes. Now, this piece between 0 and 1 has 2 extremes. There's a maximum here and a minimum there. So it says, oh, I found a minimum. I wanted to mark 0 as the local extreme cubic for this minimum, but it has a maximum and a minimum, so we can't do that. Therefore, I'm asking for a new point before I mark this as a local minimum in between. So at the inflection point it does it, which is exactly in between the maximum and the minimum, by the way. So that's why point 2 was added, to split this piece into 2. So now we have 2 cubics, one for the 0 to 2 and one from 2 to 1. And then it says, okay, we're looking for a minimum, we still do that. Well, actually, it still didn't decide that, but what it is doing now is saying we have a cubic here, and we have a cubic here, and no, it does go for the minimum. Now both are the same cubic, because the whole thing is a cubic. So this piece has the minimum here, and this piece is the same cubic actually, also has the minimum here. So it says then, okay, the minimum is closer to the center of 2, 1 than to the center of 0, 2, obviously. Therefore, we're going to use this piece. So now I'm going to use this piece. And then we jump to the minimum of this piece, which is again here. So now the step is again 0. Because we were in 2, and then we jump to 1, and then we jump to 1 again, based on this piece. And then it says again, oh, I found a local minimum. Let's mark it. And now it wants to mark 2. Yeah, the left point of the cubic, the piece of the cubic that we use to find this minimum. So then in point 2, it says there is a local minimum, the local minimum of this cubic of 2, 1 is a real local minimum of the function. After that, it says, okay, now we want to go to the right. Why? Well, it fits a 4th degree polynomial in this point now, and that polynomial, a 4th degree polynomial fitted through points that are part of a perfect cubic is a cubic, which is a 3-dimensional polynomial, but it's also a 4th dimensional polynomial. So the fit is just exactly this thing, and therefore it knows mathematically there is no maximum on that side, and there is a maximum on that side, therefore we go left. Okay, but to follow the debug output, so we got here in point 14, W is 14, twice. This is the first time, and then again after adding point 2. And then it fits a 4th degree polynomial, which, well, as you can see, is almost a 3rd degree polynomial with a really, really small coefficient for the 4th degree. And then it wants to jump to -3, which is here. This is -3. So this calls then handle extreme jump to -3. However, doing so, it says, wait a minute, what you now want to jump to, jump to means leave the whole algorithm and then ask the user code. The user code is the only one that knows what the real underlying function is. So in the end, that's going to be the neural network. What then the value is of the real function and the derivative of the real function. So it wants to jump to -3, but we already know what the derivative and the height is. Namely, we have sample 0. That's what we were given initially. So it says, I'm not going to return and ask the neural network to calculate that again, because I already have it. We have point 0. So it says, okay, this is too close. Let's reuse sample 0. Then of every new point, we have a cubic on the left and the right. So in this case, we have a cubic on this side and on that side. And it says we're choosing the maximum of the right cubic. And then again, I'm not really talking about the cubic, I'm talking about the cubic piece. And it's just a bit confusing here, because in this case, this piece and that piece are the same cubic. Well, actually, there isn't a piece here. You need 2 points plus their derivative to fit a cubic. So on this side there is not another point, so we didn't fit anything. We only have one cubic between 0 and 2. So it says we choose the maximum of the right cubic, so the cubic on the right of the last point, because the left one does not exist. So we have this cubic between 0 and 2, fitted through 0 and 2. And that has a local maximum here, and that is the maximum that we use, because we wanted to go to a maximum. And yeah, then it asserts. What should have happened is that we just jumped to that point. So we jumped to 0 from here, because the fourth degree polynomial that we fitted here has a maximum there. And then we jump again to 0, because this cubic between 0 and 2 has a maximum here. And then we notice that nothing changed, and therefore it is a real maximum. But yeah, it asserts. So I don't know. Question: why does it assert? Fix me, what to do if this fails? Well, I've been here very often, and every time something else was wrong. So I'm starting to be a bit skeptical. I think that maybe something else is wrong, or yeah, we just have to figure out why we got it, why we get here at all. So why did we leave this scope, or why did we jump over this scope? So I have to look at the real code, I guess. We'll need way more context. It's a big function, unfortunately. Oh boy, yeah, it's just find extreme. Well, yeah, I don't know. The only way to know why we get there is to just go through all of it, I think. I'm patient. So the last restart macro is here. And we'll just restart from here. So we do... yeah, that is running find extreme. So not much debug output, even though it's a large function. So we can do a rerun, and then it will run till this point. So state is find extreme. So we jump to... Let's look along here. Jump to this case label here. What was right node again? Is that already set? That must already have been set before we got here. And we got here how? So it was a reuse, wasn't it? So we got here by returning from the bottom of this for loop. Okay, then right node was set to the node after the new node. And the left node is set to the previous one. Okay, so let's ask ourselves what new node is. And then left and right node are the one left and right of that. So currently a new node, even though it wasn't really a new node but a reused node, is 0. Yeah, that makes sense. So we wanted to jump there and then we say, hey, let's reuse that. So we don't have a node on the left, but we do have a node on the right. That would be 2. So right node label should be 2. And left node should be equal to chain end. False. Oh. 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 What is it? That can't be right. That can't be right. So why is left node not set correctly? I would probably explain why we get some weird assert later on, because this is just bullshit. Yeah, then really we have to go even one further, the previous run, and then see what it does at the end. Why left node is left like that. So we did run to 106. I don't know what 105 is, but I can just try rerun 105. That is entering handle LocalExtreme. Well, good enough for me. Let's print W. It's 14, so it's probably the second time that we enter this point here. And then we're going to deal with the whole thing. So now that's set number 2, I think, as the LocalExtreme cubic. Extreme, scale value, small step, left edge node. It's going to find, we're going to find 3 samples and then fit the 4th polynomial through it. So that is all a little. Yeah, okay, here it is, the 4th polynomial. So it prints it here, draws it. Now we have the derivative of that and the quotient, removing the extreme that we found anyway. Extract the relevant root of that, and then handle the 4th degree approximation jump. I guess that just sets W to -3. So that's what we want to jump. Iteration set to left now. initialize the range. So we want to jump here, but we also want to find the real maximum, as it happens to be the real maximum, but you don't know that. So it's initializing the range where we know or expect, more like know, that the maximum must be in, and that is between 0 and 2. Yeah? I should print it, I guess. But okay, after this trigger, it did draw that, so you can see it. Now we have arrows. So the maximum is in between these two, and in fact it's going to be 0, of course. Move into range, that will then pick 0 based on, and that is pretty new code, so let's look at that. So here we see that the right off does have a flat extreme maximum on the right side. No, it doesn't on the right side. It has it on the left side. So we do next. So right off, that is 0, that is the cubic 0 to 2, does have a maximum on the left side. Yeah. This cubic has a maximum complete very left side. Therefore, we set, and then it doesn't. What? So that still doesn't work. This should be 0. It is, at least, unless this is nonsense. And actually it is chain end. It isn't. So this is really 0. And the type of this cubic is right max. That is the right part of a maximum. Left part, right part. It is the right part of a maximum. Which means that it does have a maximum on the left side. The right max is on the left side. This should have returned true. But it returns false. Why? Maybe we can debug that without restarting it. Set a breakpoint and then do this print. And then you can't continue, but well. Bit to test is the left pin bit shifted. Okay, now this is maximum, so this should be -1. No, should be 1. I'm gonna cast it to an int. I'll print it like that. I bet I do get my 1. Yep. +1 is 2, and on side is on the left side, which is also 1. So it shifted it through. What? Oh, I'm shifting it the wrong way. Yeah, well, that will do it. Quit. Now it works. Yeah. So now it does return true, and then we call extreme jump range. Sorry, extreme jump range edge. Maybe it's even 2 range edge, whatever. So we're going to jump to right off. Is that true? Yeah. Now this is, it must be to the right of this, and must be to the left of that. And right off is smack on the maximum. So we want to go there. Which means that now W equals -3. So it must be in range. So did draw the jump point. So we have this arrow, we're going to jump there. What the hell? Oh, sorry, never mind. I thought we left this function. We shouldn't leave it because there is already sample at 0. Okay, so where are we? Yeah, we returned from this function now, so we are here. Next, break, find larger than W, which that would be 2. Point to 2. Find out if this is a duplicate. Yes, it is. So -3, too close to an existing sample, number 0. So we reuse number 0. And then something went wrong because now, what was it? Left node was set wrong. Okay, what does reuse it do again? That's it last, okay. Next, so right node. Right node is the node on the right of new node. New node is the reuse node 0. And right node should be the node on the right of that, which is 2. Which is simply the node next in the chain. This is a linked list. All those things are linked left to right. So we do next, then we can print right node, and that should be number 2. And left node should be set to chain end, because it does not exist. And we don't. Left node is just left as it is. I mean, new node is chain begin. This is the first node of the chain. So left node is just not changed. Maybe it's not a problem. Maybe I just never accessed left node. So yeah, left node is still whatever it was, which is then probably 2. But okay, we should definitely not be using left node now. Let's see what happens. So now we go to the top. Running find extreme. Right has extreme is false. Right node is unequal chain end. That one is tested. It is unequal chain end because it is 2. Now we initialize. Okay, yeah, this is a temporary. It's on the stack, so I have to redo that. I have to redo the analysis. No, yeah, okay. Reusing points is not happening that often, so it's okay to redo it. And instead of as opposed to caching it every time, just for the few times that I would have to recalculate it, it's probably better to just recalculate it. So I do the analysis again, and does it have extremes? Yes, of course. Significant offset. Get the extreme of the right type, so that would be -3. Just the maximum of that thing is there. Then you have distance. .5. That is the jump distance, I think. Oh fuck, yeah, next. This window run, the drawing is done in a different thread. But all threads are stopped when you are at a prompt. Well, you can't change that actually. I could change the settings so that the other thread just keeps running. But okay, let's see. 8.5. How -3 is 5.5. So we jumped from 2 to 0. Distance of 8.5. Did we? Not really. I think we jumped from here. No. Absolute value. Oh, it's a sum of two things. Even. What? Distance between the right extreme value. What is right extreme value? That's some -3. And the new node W. What? Thought that it was -3 as well. Yeah. So right, this should be 0. Oh, right node, sorry. Yeah. Okay, so we take the distance to the right node then. A bit random. So that was 2. Yeah. Ah yeah, okay. I'm getting it. Again. So we have the node on the right of the new node is 2, which is at a distance of 8.5. What is my humongous offset? 170. Okay. The distance is less than humongous offset, therefore we accept it. And set right has extreme. To true. And then we're going to do the left one. Well, that's interesting. If new, look, we're testing new node, not left node. A new node happens to be equal to chain begin. So indeed, we are not accessing left node. We're setting that it doesn't have an extreme. So that is skipped. If right has extreme, it does. I need more context. Line 279. Okay, so here it's going to pick which cubic to use, and we have only one cubic. That still worked. Right extreme, yes. Left extreme, no. Choosing the maximum of the right cubic, because the left one does not exist. Handle jump, handle extreme jump. So now we're jumping to the maximum of the cubic 02. Yeah, just next. Can print W. So -3. The jump has been executed. I don't know, Felix. Sorry if it's annoying. I don't hear it because I have headphones on. It's probably blowing a bit too fast because on CPU is 0. Update scale. The scale critical point type is to use cubic as an extreme, and it is a maximum. Then the critical point type becomes maximum. The critical point itself becomes extreme then, which is -3 again. And we said left edge and right edge. So left edge is 0 and right edge is 2. Initialize matches. Well, I don't know anymore what that does, but I guess it works. Huh? Yeah, okay. This just determines the scale. It's kind of silly to go so slow. That means it's going to run left and right and then find out when poles deviate too much from the cubic fit, and they never do, because the real function is even a cubic. Everything matches perfectly. So the scale is set to the whole thing. It's set to 8.5 because we use 5.5 instead of 14, which is because 14 is beyond the inflection point. So really we found this point and that point and that point, but because this point is beyond the inflection point, I'm using the inflection point itself. And then we determine the scale as, again, the distance between 0 and 2, which is 8.5. So that's the scale value then. And that was drawn here, so you know an arrow here, and that's just, you know, to get a feeling for how fast this thing is changing. Well, this is more or less the scale over which the function changes. So if we want to go to the left from here, then we take this step. So we would end up somewhere here. Ask for a prop there. Can't go too fast, can't go too slow. So we do not have to keep going. If left off equals chain end. I thought left off was equal to 0. Or W is less than left off. Well, this, wait, what? Oh, okay, and that asserts. Yeah, well, that's because it is a not fuzzy compare. Well, that's correct. But this one would have a problem. You see, it says it must be less than or equal. Sorry, it must be less than or equal. It is equal, therefore this is just the wrong assert. I should have used an equal sign here. And in that case it will work, because -3 is exactly equal to -3, but moreover we did set W to literally this value. So no matter what it is, it's gonna be equal. I want to see it assert before, you know, I'll make it fuzzy. I think it probably should just work. And the way it is now, it's wrong. I think I refused to add an extra character here because I thought, yeah, but floating point round off errors, who cares about equal? But now I set W literally to this value. It does matter. What would it mean if it would really be out of range? That is, the right off is left of W. That's impossible. That is impossible. We are in range. That was checked before. think this is just an old paranoia check before I added shitloads of code that makes sure that my W is in range. Hell, probably even before I had the range. No, it's not. Yeah, well, I don't know. Quit. Yes. VI. Bleep. That must be an equal sign. And what is it really doing is just checking that we are still in range, which is, well, it should have been done before, I think. Maybe not. Okay, I had a function called debug something within range. Yeah. So why would that? Oh. Is it not the same thing then? What does within range do? It says return left of equals chain end, or W is less than or equal left of. Left of is equal to chain end, or W is less than or equal left of. It's exactly the same test. And the other one is, yep, right of is chain end, or right of is less than or equal W. Exactly the same. That was not checked before though. So why would we always be in range at this point? No jump step. Could end up anywhere. Okay, I still have absolutely no clue why we would be in range. So, but apparently it requires attention if we are not. I just left off right off. Also so vague. If we enter handle LocalExtreme, we're going to do range initialization anyway, is it, or we not? Neutralize range. So this is being called unless we return before that point. Which would be a return false, which is just a request to abort H instruction. This is a request to get an extra sample, I think. Yeah, difficult, but I don't think or just don't think. I don't know. I have the feeling that it's just not necessary to do this anymore. I don't know. Let's just wait for the next assert. Okay, so now we have 2 is marked as this minimum and 0 is marked as that maximum. And then and then we still don't leave this function, no. Now the test suite is complaining. That's probably not as bad. Right, max, yeah, it's just the cubic node is the right part of a maximum, this part. But expected is set to something else. Well, right, also right max, but also left min. So it was expecting to see this thing, the right part of a maximum followed by the left part of a minimum, but the recent code has cut that thing in two by adding the 2 here, which was necessary. So the expected is no longer correct, and we have to fix it. I'm gonna leave that as is. Felix, yeah. Before you go, I'm gonna read what you all typed, which is quite a lot. So I had been concentrating a lot, but I will read it. So I hear gradient descent, but it's not grounded in knowing what the root concepts of it mean. Yeah, gradient descent is usually something that you take a step linear with the derivative, which means that you approach say the minimum of a parabola already in infinite steps. So you take a step and then you say you cover 90% of the distance, and the next step will again cover 90% of the distance. And then again 90%, and then again 90%. So you get close, but not exactly on top of it. And I completely departed from that idea. I still call this gradient descent because it's finding the minimum of a global minimum of a function, but really only so people can recognize what I'm doing by just looking at the title. That's why it's between double quotes. I'm reading what you're saying. I haven't thought about more than one dimension yet. This is just a simple function still. No, my algorithm finds a minimum that has left and right of it two minima that are higher, and then it stops. And it's completely single-threaded in doing so. I have a you ask, you have a neural network in this code? Well, I have a lobotomized single neuron that I worked on. So hardly, no. Describing it in English logically for an AI and how many dimensions would be ideal computationally. Sorry, I have no clue. It's all new to me, and I'm doing everything from scratch. So I'm not really deep into useful AI or anything like that. I would say yet, but yeah, we all know I'm never going to reach that point. I'll be dead before I would reach it. If I had eternal life, and well, definitely a yet. You know, I could just in 1,000 years I would have a general AI if I just continue. I was seeing someone one time saying they should make a really complicated program that they know really well and use parts as example in the YouTube context. Are you working out why the high maximum is not at 0 anymore? Yeah, sorry, that's out of context, so I don't know what you mean. 0 on the x-axis? No, it never has been. Okay, oh, let's see you. Maybe you already left, but it's okay. I should go too. I could start with setting it to right max because that's what it is now. But we get it more often and it probably has to be something else. Yep, great. That's the other one. So now we have the maximum on the other side. Also splits it into and this should assert them. Yeah. So now we need a different expected here. See if we can understand why cubic is right min. Well, that I don't see. I mean, right min is the right part of a minimum, though that would be the cubic between 0 and 2. What, the cubic node 0? It is 0. Why are we talking about 0 then? I mean, the next jump point is already here. So, not even sure which one we found first, 0 or, of course 0, yeah. So we jump into 0, we go to 1, we say, yay, we found a maximum, but we have a minimum here, therefore we add 2, jump again to 1, jump again to 1, then we store in 2 that this is a maximum, hence the 2 here, and then we go to the minimum, so then I think we jump to here. Then there's no cubic on that side, so not pick the cubic between 0 and 2 and jump to the minimum, which means that we stay at 0, and it says, yay, 0 is a minimum. So then that is the last cubic. Maybe that's why cubic node is 0. But then we want to go to the right, which means that yeah, I'm not sure what it did actually. Did it find the maximum again? It would be bad. It should just go straight from here to there. Passing that point, just taking the opposite. But it's not going to take the opposite of a maximum. I don't think I wrote that code yet. What it should do is being here, wanting to go right to a maximum, and then looking at the neighbor, which I'm setting but not using it. So we should have debug output actually about the neighbor was set to something. Something with a neighbor. Nobody sees a neighbor. Sorry, what was that output anyway? Yeah, this setting left or right neighbor. Oh, God, press the wrong button. Neighbor. There we are. One neighbor. Setting a left neighbor of 2 to 0. Yeah, the 2 here means not the sample 2, but the cubic 2, 1, which has a maximum here. So it's more like this 2 here. And then the left neighbor is set to 0, which means this is 0. So that's correct. Or then do it the other way. Of course, this one has also that one as a number on the right. I have to add that as well. John is the neighbor of take another name. Yep, I want to know where the cubic node comes from. I finally figured out a name. So John is the neighbor of Marie, but Marie is not the neighbor of John. How is that possible? The cubic node. I was going to search for that. Yes, cubic node. Ha 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 ha. There's only one cubic. No, 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 no. Not anymore. Not after this. Yeah, I expect it was set to right max. Yeah. I guess originally this was right min left max. I think the last cubic would be the most interesting thing. It's probably the last one that we found, or not? It's the first one that we found. It is rerun the whole thing. Not rerun it, just run everything from the beginning. So we do 0, 1, add 2, and find everything. So annoying. Okay, first -3, again -3 after splitting it in two, and then 40. So this one is found first and then that one. That means that this one is the last one that we found, and therefore I want to test just this shape, I guess. Now, how do I get the last cubic? It's not the first one. It is. I don't know. Cubic used. Maybe we can just print it. Let's continue till we crash up 7. Print GDA cubic used. I mean gradient descent algorithm. Cubic used is ID 2, so yes, that's the one that we want. You can just make a debug accessor for it. I have an accessor for it. Okay, let's let it crash again first, so we can see that it really works this time. Is in. This should now be left max. Yeah. So now I have to set expected to that value. That then would be if what is the thing called? Your maximum last. Now we should not crash anymore. What am I doing? Cool, the test should pass. And it goes wrong almost immediately. On this test, seriously. No. We stopped because we couldn't go any further. The comment is wrong. The node does not have the slot for local extreme, then it must be a local extreme cubic that has its extreme outside of the cubic, on the side of the direction. Okay, we stopped too soon. Or we just couldn't go any further. Thank you very much. Because node is just up. Type up. It's definitely not a local extreme. It does not have an extreme. It is not a local extreme. It is equal to chain begin. Also nonsense. Okay, I'm gonna stop. Think about this tomorrow. Good night.